SDKY focuses on mining and lime kiln technology, providing customers with full process EPC general contracting services from project planning, design and manufacturing to installation and commissioning. The core process flow is as follows. Limestone, the raw material, and anthracite, the fuel, are conveyed to their own warehouses separately. The precision vibrating feeder at the bottom of the warehouses works in coordination with the metering system to ensure that the two materials are mixed and weighed in the most optimized proportion. The well-mixed materials are carried by the feeding trolley and conveyed to the top of the kiln through the track, completing the automatic feeding. The materials are accurately discharged into the distributor at the top of the kiln. Then the empty trolley goes down back to the bottom. When the trolley gets back the loading position at the bottom of the kiln, the bottom plate automatically triggers the interlocking device, driving the distributor on the top of the kiln to rotate at an even speed for material distribution. At the moment when the trolley is fully loaded with new materials and rises and leaves the contact point, the distributor synchronously stops working and shuts down. This design of bottom triggering, top action ensures the precise timing of material distribution, and is the key link to guarantee the uniformity of ventilation and heat distribution inside the kiln. The evenly distributed materials run from top to bottom in the shaft kiln, passing through the preheating zone, calcination zone, and cooling zone in sequence. In the preheating zone, the material undergoes stable countercurrent heat exchange with the high-temperature flue gas rising from bottom to top. The material is uniformly heated from room temperature to the decomposition threshold, achieving the initial decomposition of part of the calcium carbonate. The calcination zone is the core reaction zone. The temperature is precisely controlled within the optimal range of 950 to 1100 degrees Celsius. Calcium carbonate absorbs a large amount of heat and is converted into active calcium oxide. The hot lime after calcination enters the cooling zone. It conducts efficient heat exchange with the normal temperature air blown in by the high-pressure fan at the bottom of the kiln. The finished lime is cooled to approximately 60 degrees Celsius, while the cold air is heated to become high-temperature combustion-supporting air, which is then fed to the calcination zone. Meanwhile, the kiln shell adopts a multi-layer composite structure composed of new insulation materials, forming an efficient heat insulation system. The finished lime is discharged from the corkscrew ash removal system. The multi-layered conical structure of the system achieves uniform ash discharge across the entire cross-section of the material through slow rotation, effectively avoiding local emptying or material shedding. The lime is discharged through the central discharge port into the matching sealed star-shaped unloader. Then the lime is conveyed by the belt and elevated by the bucket elevator to the silo for storage. At the top of the kiln, the flue gas that has completed heat exchange enters the environmental protection treatment system. All dust collected by the two-stage dust removal system is returned to the main finished product belt conveyor through a centralized screw conveyor system. The flue gas, after dust removal and purification, eventually enters the lime calcium sulfate desulfurization system. The entire production process is centrally monitored and precisely regulated by an advanced PLC automatic control system. With its profound technological accumulation and rich project practice experience, SDKY has successfully finished 116 high-performance production lines worldwide. We look forward to helping you create a better future.